Let's look at graph transformations. For example, let's sketch y is equal to 3 minus 2 times the quantity x minus 1 squared by using graph transformations. Now, we already saw in the Part 1 lesson on graph transformations what this 1 and this 3 will do to the graph. But what does this 2 and this negative do? Well, we have the following. That if c is greater than 1, to obtain the graph of y equals c times f of x, we vertically stretch the graph of f by a factor of c. If we divide by c, then we vertically shrink the graph by a factor of c. And if we multiply the x inside the function by c, then we horizontally shrink the graph of f by a factor of c. But if we divide the x by c, then it's a horizontal stretch of this graph. So these four here determine this stretching and shrinking. Whereas these last two down here determine the reflecting. And what they say is that to obtain the graph of y equal to negative f of x, we reflect the graph about the x-axis. And if we multiply the x inside the function by a negative, then we reflect the graph of f about the y-axis. So we still start with our base function, y equal to x squared. So let's say that this is the y-axis, and this is the x-axis. Y equal to x squared looks like this, where this point here is 0, 0, the origin. We also have that 1 lies on the graph, as well as negative 1, 1. All right, so remember, what does this minus 1 do inside the function? This rigidly shifts this graph 1 unit to the right, which means to each x coordinate here, we're adding 1 while leaving the y coordinate alone, which means that 0, 0 will move to 0 plus 1, or 1, 0. 1, 1 will move to 1 plus 1, which is 2, and then 1. And negative 1, 1 will move to negative 1 plus 1, which is 0, 1. Therefore, y is equal to x minus 1 quantity squared will look like this. So here's the y-axis. Here's the x-axis. So here's 1, 2, and 1. So 0, 0 moved to 1, 0, which is here. 1, 1 moved to 2, 1, which is here. And negative 1, 1 moved to 0, 1, which is here. So this graph will look like this. So this is the point 1, 0. This is the point 2, 1. And this is the point 0, 1. All right, now let's discuss what this 2 up here does to this graph. Well, we're in this first case down here, aren't we? Which means that we're going to vertically stretch this graph here by a factor of 2. Which means what? Which means for every y coordinate that you see on this second graph, we're going to be multiplying that y coordinate by 2. So the graph of y is equal to 2 times x minus 1 squared will look like this. Say this is the y-axis and the x-axis. This is 1, 2, and this is 1, 2. Now this point over here, 1, 0, isn't really going to move because we're multiplying the y coordinate by 2. So we're still at 1 and then 2 times 0, which is still 1, 0. So we're here. But these other 2 points will move. This is going to move to 2, and then 1 times 2, which is 2. And this is also going to move to 0, and then 1 times 2, which is 2. So we have this point here and this point here on our graph. And therefore, this function will look like this. So we're vertically stretching it. All right, looking back up here to the function, now what does this negative do here? Well, looking down here, that means that we are going to reflect this graph about the x-axis. That is y equal to -2 times x minus 1 squared will look like this. So if this is the y-axis, and this is the x-axis, this is 1, 2, this is -1, -2. We still have the same vertex here, but now those other 2 points, 0, 2, and 2, 2, are going to be flipped down below the x-axis to 0, -2, and 2, -2. So this graph will look like this. And finally, the graph we're looking for, this y is equal to 3 minus 2 times x minus 1 squared, will be a vertical shift up 3 units of this graph. That is, it's going to look like this. So here's the y-axis. Here's the x-axis. So the point 1, 0 is going to move to 1, 3. 1, 2, 3. Because we need to add 3 to every y coordinate. And the point 0, -2 is going to move to 0, +1. And the point 2, -2 is going to move to 2, 1. That's here. So the graph we're looking for is this. All right, and this is how we work with graph transformations. Thank you, and we'll see you next time.